talk about some of the most common causes of faults when you're using temporary fences, like this polywire reel, or afterwards we'll talk about netting. The single most common fault you're going to find on a polywire fence is going to be that your conductor, your polywire, your turbo wire has fallen out of your step-in post. That means that your conductor is coming in direct contact with the steel leg, typically steel on this type of step-in posts, and that's a short to ground because the steel goes right into the soil. So if you have an adequately sized energizer, then a fault like this is not going to pull down your voltage too much. It's not going to be an enormous problem, but little faults like this add up and you should know how to prevent it. So when the wire is up in the ring, whether it's a ring top style post or a pigtail post, you can see that if the post is rotated this direction, then the wire can easily fall out of the ring because it's in line with where the slot is. So it's always best if you rotate the post a little bit in the other direction, and then the wire can't fall out as easily. The other thing you'll notice with these portable posts is on this model, it has a bit of a little spike here on the front, and that's long enough that if you drive that into the soil, that helps prevent the post from rotating. If you're still having issues with the post rotating, you could switch to a heavy-duty ring top post, and in this case, instead of just a small spike, there's actually a long metal spike here, and if you can get that down into your soil, it's definitely going to prevent that post from rotating. If you're using a multi-wire fence, then these multi-wire insulators can also pop off, pretty common, and you'll notice that especially if you use these posts for a change of direction. So if your wire is coming through here and changing direction like this, then you can actually pull the clip right off of the post. So if you have to change directions with these multi-wire posts, you definitely want to make sure that your wire is pulling into the post from the opposite side of the post rather than only pulling on the insulator clip, because if it's pulling this way, it can't pop off. While it's not technically a fault, the way that you hook up your portable fence can have a big impact on its performance. And what we're really talking about is making sure that your connection to the hot wire is adequate so that the maximum current can flow into that polywire. And where that's really going to matter is when you do have a fault like the one we showed with the post. If you have a bad connection back to the hot wire on your permanent fence, then the performance of your polywire is really going to suffer. So just having the polywire in contact, touching the hot wire, is going to be a poor quality connection. So a better way to do it is using one of these dual purpose handles like this Zammer or this dual purpose handle from Gallagher. So what these have is a metallic hook that's connected directly to the polywire on the end of your reel, and that allows you to hook it onto a hot wire, and that will energize this polywire. In the case of this handle, the steel conductor goes all the way through the handle with the hook right out at the end, and in the case of the Gallagher, the polywire is tied right onto it at the back of this handle. These handles also feature an insulated hook here on the front that's plastic, so you can hook that up. If this is energized from the reel side, you can hook that plastic hook up to a fence like a barbed wire fence or something that you don't want to energize, and the conductor stays away from it, so you can energize it from the other side. If you have a normal hook on the end that doesn't have a conductive part, then you want to think about using an alligator clip. So you might want to jump directly from your hot wire on your fence over to your polywire like this, and that'll create a highly conductive connection. If you need to energize the fence from the reel side, then you'll look on the side of these Gallagher reels, there's this hoop or a metal loop that comes out, and that steel wire goes all the way through and it's touching all of the polywire. So if you hook onto that and hook onto your hot wire, you get a really high quality connection that's going to pass through the full current. If you think of your electric fence like a water system, then your energizer is a pump, and you're pumping the water through a pipe, and that's your conductors. And when I'm talking about resistance in these connections, that's like a restriction in your pipe. So it's like kinking your garden hose. And you know that when you kink your garden hose, you reduce the amount of flow that can come out the other end of it. That's the same effect that a poor quality electrical connection will have in your fence, including the connections to your polywire on the reel. So if you make your electrical connection by just having your polywire sitting on top of the hot wire like that, that's going to create a lot of resistance right here. It's going to be like a kink in your hose. And in an electrical system, resistance equals heat. And when this connection heats up here, especially if you have a short on this polywire and there's a lot of current flowing down the fence, a lot of heat can build up here, and that heat can actually melt these plastic strands in the polywire and damage it over time, causing a weak spot that's going to be more susceptible to breakage. The last fault I want to talk about for these polywire reels is part of the reel itself. So if you look closely at how these reels are manufactured, there's a plastic collar inside of this steel frame on both sides. On this side, it's sort of a plastic washer. And these parts inside of the hub are insulating the polywire from leaking current through to this metallic frame, which is attached to this hook. So if you're energizing your fence from the far side, from the hook side, and then you hook this steel frame onto your ground wire or onto a barbed wire fence, and there's current leaking from this polywire onto this frame, that's going to create a short. And that can be a difficult short to find because you're expecting these devices to work properly. But over time, that plastic can degrade, and where the handle gets close to the frame, you can get some arcing there. It's best practice to just hook this reel onto your hot wire, and then you know you're not going to have a dead short there. If you do have to hook it to barbed wire, that's just something to pay attention for if you have a short that's difficult to diagnose on your reel. All these parts are replaceable on these Gallagher reels, and so when they do wear down or break down, you can easily disassemble this and put in replacement parts so that it's functioning properly again. Let's talk about some of the most common faults on polywire net fences like you would use for poultry or for sheep. Much like the reels we were just talking about, the quality of the connections matters a lot, and especially with netting, because there's always a lot of current flowing into your netting because of vegetation touching these many wires. So the quality of your connection between your hot wire fence that's feeding it, or between your energizer and the net, and between nets, if you're using multiple nets in your system, is really important. And most brands of netting are going to have some sort of clip on the end that's clamped and crimped to all of the conductors, where they all come together at the top here. So that's the place where you want to make your electrical connection to have a high quality, low resistance connection. In the case of this clip, you can actually clip this directly onto your hot wire of your fence, and that's going to make a great connection. If you're unable to clip this to your fence for some reason, that's another great place to use an alligator clip. Clip it right onto that metal plate, and then clip it to the hot wire, and make sure nothing's coming in contact with other ground wires or barbed wire on the system. If you're close to the fence like this and you're using your permanent fence to hold up your post, it's better to, instead of tucking it in the wire where it could short out against something, it's better to use something non-conductive, like baler twine works great because it's made of plastic, and just pull it around and make your connection to the fence to hold up your post like that, with somehow just tie it up to hold that tension, and then you know that nothing on this fence is going to short against anything on this fence. Another common fault would be if your steel spike at the foot is coming in contact with one of your conductors. And this can be more of a problem with the double spike posts, because the second spike can actually snag around the conductive wire without you really noticing, and you can set it up like that. And then just like with your step-in posts, you're going to have a direct short to the soil through this steel foot. By far, the most common fault on your netting fence is just going to be the vegetation load of all of the plants touching it. And every individual blade of grass that's touching those conductors is just a small leak, but when you get this whole 100 or hundreds and hundreds of feet of netting, all of those little leaks add up, and netting takes quite a bit of current and takes a larger energizer to run. One thing that we do in order to reduce the amount of leakage through the vegetation at the bottom of the fence is we like to disconnect the bottom conductors from the netting, and I'll show you how to do that. If you look closely at the way your netting is made, you'll see that the bottom strand is non-conductive, but the next strands, even starting at 3 inches and 6 inches in height from the ground, are conductive wires. And each conductor comes along and then is tied at the end and goes up, connecting together with each additional conductor as it goes up until you get to the top and you have them all wrapped together at the top, however many wires are on your horizontal wires are on your net. These vertical stays are not energized. So what we want to do is look at those bottom 2 conductors, or as many as you want to disconnect, and we do 2. So I'll take those bottom 2 conductors and look at where they go up, and where they go above the second conductor but before they reach the third, I'm going to cut those conductors right there, being very careful to not cut the stay, which is different and doesn't have the conductive steel wires in it. So I'm going to cut those off right there. And then if these were to come back in contact, they can still short out and send current down to these lower wires. So I like to melt the ends of these together, just like you would with cutting a polypropylene rope or something. I just burn the plastic end with a lighter and just kind of squish the, don't burn yourself, be careful, but when the plastic's a little bit melted, you can kind of squeeze it together, and that'll keep those conductors together with themselves and keep them out of the way. You can see now we've removed the bottom 2 conductors from the circuit. Only the non-energized stay is intact there. And in our case, we're mostly keeping in poultry and we're keeping in dogs with these nets and keeping larger predators out. If you're having issues where you're using netting to keep out very small predators, muscelids like a weasel or something like that, then you may really want to try to keep those lower conductors intact. But then you're going to have to really focus on vegetation management and either mow or trample down the forage where you're setting up your netting, and don't leave your netting there so long that the vegetation regrows coming into contact with that fence.